Hello everyone. Welcome to our course, Green Economy from China's Stories. After learning ecosystem service value and the assessment significance, let's learn about the research progress of the assessment of ecosystem service value. Let's look at the research on the assessment of ecosystem service value. First, we will come to the international research about the assessment of ecosystem service value. The assessment of ecosystem service value can be traced back to 1925, when Drew Marx of Belgium first took the expensive method to assess the value of wildlife. In the following decades, the travel cost method, contingent value method, and other methods are applied and developed in the assessment of ecosystem service value. Since the 1960s, there has been a proliferation of studies by different scholars on assessment of ecosystem service value at different scales and types, and a variety of assessment methods have been used. From the international perspective, researchers can be summarized into the following 4 types. First, global or regional ecosystem service value assessment. The representative one is the classification and comprehensive assessment of the global ecosystem service value, put forward by Costanza and other 12 scientists in the world in 1997. In estimating the global ecosystem service value, Costanza et al. First divided global ecosystem services into 17 sub-ecosystems, and summed them to calculate the service value generated by the global ecosystems each year. The total annual value was 16 to 54 trillion US dollars, with an average of 33 trillion US dollars. What does it mean? It is 1.8 times the global gross national product in 1997, often called GNP. Another large-scale assessment of global ecosystem service value is the Ecosystems and Human Well-Beings Research Program, carried out by Millennial Ecosystem Assessment at global scale and 33 regional scales. This is an international cooperation project launched on June 5, 2001, coinciding with the World Environment Day, sponsored by the World Health Organization, United Nations Environment Program, and the World Bank, etc., under the call of the United Nations. This is the first integrated multi-scale assessment on global ecosystems to assess the threats that global ecosystems, plants, and animals face. Second, watershed-scale ecosystem service value, for example, Gren assessed the economic value of the Danube River in 1995. In 1997, Dixon discussed the value of soil and sediment conservation in a UK watershed, and its role in guiding watershed management. Some Indian scholars assessed the value of ecosystem services for drought mitigation in Indonesian watersheds. Third, assessment on value of an individual ecosystem. For example, Turner extensively assessed the economic value of wetlands in 2000. Hanley et al. Assessed forest landscape and recreation values in 1993. In 2000, Loomis assessed the total economic value of the Platte River ecosystem in the U.S. In 2003, Lau assessed the value of marine mangroves along Pacific coast and the significance for environmental decision-making. Fourth, assessment on conservation value of species and biodiversity. For example, Jacobson et al. Used the contingent valuation method in 1996 to assess the value of all endangered species in Victoria, Australia. In 2003, Mendoka et al. Used WTP and population survival analysis model to analyze the monetary value of species like golden lion tamarins in Brazil and predicted future survival probabilities for each species. In 2004, Bandara et al. Discussed the net benefits and policy implications of Asian elephant conservation in Sri Lanka. Compared with other countries in the world, China's research on assessment of ecosystem service value is late, but rapid progress has been made in recent years. In 1999, Xue Dayuan et al. Used the expense method, travel cost method, and contingent value method that were rarely used at that time to detailedly analyze and assess the indirect use value, non-use value, and tourism value of biodiversity in the Changbai Mountain National Nature Reserve. However, based on his literature, Xue Dayuan is one of the earliest scholars in the country to carry out ecosystem value assessment, but his assessment was not based on ecosystem services. Ouyang Zhiyun et al. First adopted concept of ecosystem services in 1999 and assessed 6 service functions of terrestrial ecosystems in China. He pointed out that the first choice of assessment parameters could lead to biased conclusions. In 2003 to 2004, Ouyang Zhiyun et al. Assessed value of ecosystem services in large-scale areas like China's land surface water, grasslands, forests, and Hainan Island. The research results of Ouyang Zhiyun et al. Have great significance for China's ecology in the present stage, which has gradually accelerated the empirical exploration of ecosystem services and their value. In 2003, Xu Zhongmin et al. Used the direct market method, contingent value method, environment choice model, and other value assessment methods to conduct field surveys and assessments on ecological restoration in Jiangye area of Gansu in the middle and upper reaches of Heihe River and Ejin Banner of Inner Mongolia in the lower reaches of Heihe River. They obtained the total economic value of regional ecological restoration and conducted a comparative study on these methods. Based on the assessment model proposed by Costanza et al. In 2003, Xie Gaudi et al. Investigated more than 200 ecologists in China and proposed equivalent factor table of ecosystem service value in China, which was a representative study. In 2012, Zhu Qunquan proposed to incorporate the gross product of natural ecosystems, i.e., the sum of value of final goods and services provided by ecosystems, into China's Sustainable Development Assessment and Accounting System. This idea and the launch of the project have once again promoted the assessment of ecosystem service value in China. Comparing the studies on the assessment of ecosystem service value between China and other countries in the world, we can find that the paper of Costanza et al., published in Nature in 1997, is most striking, which has a profound impact on the studies of ecosystem service value assessment, physical assessment method, energy analysis method, market value method, and opportunity cost method used by Costanza et al. In 1997 have the greatest impact on the calculation of global ecosystem service value and asset capitals, and have become the basis and reference for many subsequent studies. Next, please watch a video.
昨天，云南省林业和草原局发布了2018年度云南省自然保护区森林生态系统服务功能价值评估报告。
这次评估范围确定为2016年底全省范围内划建的20个国家级和38个省级自然保护区，总面积达218.74万公顷，占全省自然保护区总面积的76.28%。 经过评估，这些国家级、省级自然保护区2018年提供的森林生态服务价值达每年2129.35亿元，自然保护区每年每公顷的森林生态服务价值达13.02万元，每亩价值8680元，是云南省平均每公顷年森林生态服务价值4.26万元的3.1倍。其中，自然保护区每年的生物多样性保护价值达800.82亿元，占总价值量的37.61%。每年涵养水源和保育土壤这两类生态服务价值分别为623.45亿元和384.99亿元，占总年生态服务价值的29.28%和18.08%。每年自然保护区森林固碳饲养价值为224.28亿元，积累营养物质价值为14.66亿元，净化大气环境价值为81.15亿元。这三类生态功能的服务价值总和达320.02亿元，约占总价值的15.03%。
从评估的结果来看，就是我们的天然林要高于人工林，密林要高于这个疏林，近程过属林高于这个中幼林。在西部和南部，我们的这个生态服务功能价值高。
Thank you. See you next time.